Hi everyone, welcome back to the Civrays InMoov. Wait a minute, where's Ralph gone? Oh, ever since we gave him those legs, he keeps wandering off. George, can you see if you can find Ralph? We need to make another video.
Right, I'm gonna see if we can find that Ralph. Where could he be?
Oh dear. Well, if George ever finds Ralph and gets him back into the garage, what we're going to be doing in this video is I'm going to give you a brief overview of the electrical system on my robot, and then we're going to be looking at replacing some of those green prototyping boards that I was using with some nice new shiny PCBs that I've designed and had manufactured by JLCPCB. We'll get them fitted on the robot. I'm going to design some new mounting brackets for some of them and get them all attached. And then I'll try and get the thing powered up just to make sure that everything is still working. So let's take a brief overview of the electrical system. So a few people have asked me if I could share a wiring diagram for the robot, but the simple answer up until now has just been no, I don't have one. Up till now I haven't had a wiring diagram. So I've had a go at trying to put one together. So we'll go through it here. I'll start with the 12 volt circuits, the main power supply. So we start with a pair of 3S lithium polymer batteries. Now I've got some big chunky terminal blocks in the front of my robot. And I basically connect the batteries into those terminal blocks with some 14 gauge silicon wire. I connect the second battery in exactly the same. Then I've got the first power switch. These are the illuminated switches on the back of the robot. And I take a pair of silicon wires into that switch. And these are slightly thinner. They're 20 American wire gauge. And then we've got the next power switch and another pair of wires. And the next power switch with another pair of wires. And then the last power switch again with another pair of wires. So each power switch is feeding power into a buck converter. So we've got the first one with a pair of wires running down into it, and that is for the left arm and stomach. The next one is feeding into another buck converter for the right arm and head. And then the next one is feeding into a slightly smaller 3 amp buck converter for the Raspberry Pi and screen. And then the last one's going into another small 3 amp buck converter for the NeoPixel. So if we take a look at the left arm and stomach, we start with the left Arduino Mega, and we'll bring in a standard breakout PCB, and we connect to that the 3 left shoulder servos. Now that connects to the left Arduino Mega via a 14-way ribbon cable into the shoulder connection. And then I've got my bicep breakout boards where we connect the left bicep servo, and that's connected to the left Arduino Mega with another 14-way ribbon cable. And then we have another standard breakout PCB, and to that we connect the left wrist, thumb and finger servos. Now this piggybacks off of the bicep PCB with another 14-way ribbon cable. And then finally we've got the stomach breakout PCB, which actually has an Arduino Nano mounted onto it. And there we connect the stomach servos, and again another 14-way ribbon cable back to the left Arduino Mega, and that connects to the stomach connection. And then for power, we've got our first buck converter. This is a 12 amp buck converter, and it's set up to produce 6 volts. So we take a pair of power cables into the bicep breakout PCB. These are again 20 gauge silicon wire. Another pair piggybacks down to the standard breakout PCB that's in the hand. And then we have another pair coming from the buck converter into the breakout PCB for the shoulder, and another pair that actually go down to the stomach breakout PCB. Then we have a small 3 amp buck converter, and that also feeds power into the stomach breakout PCB. And if we look at the right arm and head, we've got the right Arduino Mega, standard breakout PCB in the head for the eyes, jaw and neck servos, and that connects to the Arduino Mega via a 14-way ribbon cable. Another standard breakout PCB for the right shoulder servos, again back to the right Arduino Mega with a 14-way ribbon cable. Bicep breakout PCB for the right bicep servo, and another 14-way ribbon cable, this time going to the arm connection. And another standard breakout PCB for the right wrist, thumb and finger servos, which again piggybacks off of the right bicep breakout PCB by another 14-way ribbon cable. And for power, we've got the second 12 amp buck converter, again set up for 6 volts. Take a pair of cables up to the head breakout board, another pair of cables to the shoulder breakout board, and finally a pair of cables up to the bicep breakout PCB. And then we piggyback down to the breakout PCB in the hand. So that's it for the right arm and head. And then lastly, we've got the Raspberry Pi 4 and touchscreen and USB hub. So from another small 3 amp buck converter, this time set up for 5 volts, I'm feeding power directly into the GPIO headers on the Raspberry Pi. I'm connecting to a 5 volt connection and a ground connection. Then I'm taking a HDMI cable from the Raspberry Pi to the screen. And I'm taking a USB cable from the Raspberry Pi to the screen. Now this provides both the touch interface and the power to the screen. I'm taking another USB extension cable down into the USB hub. And I've got a cable coming out of the USB hub to the left Arduino Mega, another cable coming out to the right Arduino Mega, and lastly another USB cable coming out to the Arduino Nano. So that basically covers most of the wiring on the robot. The only 2 bits that I've not shown are the audio amplifier. I've got a cable coming from the Raspberry Pi audio output into the audio amplifier, and then the speaker is connected to the audio amplifier. And then the only other thing is the NeoPixel, which actually connects to the stomach breakout PCB. That's fed from the 5 volt power supply there, and there's a little, I think it's a 10 volt, not sure how many microfarads capacitor on that as well. I'll need to look into that. I suppose the only other thing is the PIR sensor, but that basically covers most of the wiring. I hope somebody found that helpful. You've been asking for a wiring diagram, so that's the best I could come up with. So we've got a few goodies here from JLCPCB. I originally designed these boards, and these are going to go on our Arduino Megas. I thought they've just replaced the messy ones that I made earlier, the green ones that we had before, with some slightly neater ones. What I've done is I've made them all identical, and the plan would be, we only need 2, so the left and the right board will be exactly the same, but we've got on here head, shoulder, arm, fingers and stomach. It's a little bit misleading because the arm actually means the hand, really. The fingers are the finger sensors. The shoulder, we've got things like the OMO plate, the rotate and tilt servos in the shoulder, whereas the arm, we've got the elbow, the wrist and the finger servos, and then this fingers being the analog sensors if we want to use them. And we've got the stomach. So what my plan would be is that both the left and the right would have a shoulder and an arm. So we'll have a left shoulder and a left arm, a right shoulder and a right arm, and then we'll just use one board for the head, having a cable going up to the head, and we'll use the opposite board for with a stomach going down to the stomach. So it means that one of the head connections and one of the stomach connections are redundant, but doing it this way it just enabled me to keep the boards identical. Now there's no real power on here other than to power the actual Arduino. Well, I have got a power connector for that with a resistor and an LED. We've got a reset button, we've got a few auxiliary outputs here. I have got the connection up here for the PIR sensor. Again, we'll just use it on one of the boards. And I'll just put these together and we'll see how we get on. So I've soldered on the components for 2 boards. Got the headers on the back as well, so we can plug them into the Arduino Megas. And then we've also got these servo breakout boards. They came on about 15 on a panel, and you can just snap them off. They're V-scored, so you could just snap them off. JLCPCB charged the same price for a 100 by 100mm panel, no matter how many boards you got on it. So I just filled it up, which means I've got absolutely loads of these in here. If anyone in the UK wants one of these or a few of these, just contact me. I can post you some. So if we take a bit of a closer look at these breakout boards, we've basically got a power connector, screw terminals for the power to come in, ribbon cable connector for the signal wires coming from the Arduino, and then the actual servo headers here. And you can see we've got, coming from the power connector, some nice thick solder tracks coming around for the power. So hopefully they'll work. So I've taken the screen and the Raspberry Pi off, so that's out of our way. So it gives us access to these Arduinos. So I need to get these old green circuit boards off, and I think I'll start with this one on the left here. Probably would be a good idea to remove the batteries, wouldn't it?
Should think so. Dad, you have a cable dropped on the floor.
Yeah, we don't need that. This is a bit awkward. It's not very good in here because to get to these screw terminals here I have to take this battery mounting out. I think we've got no choice, we're going to have to take that out. A little tricky to see in here, but there's a bit of a problem. I can see the board's not completely pushed home. And the problem is the pins on the back of this green LED in there are hitting on the USB port. So I'm going to have to try and do something about that. So I've cut them as flush as I can, and then I've stuck 2 layers of insulation tape over them. So hopefully that will insulate them, stop them shorting out on that USB connector. There's the new board in situ there. I've plugged in the arm ribbon cable, and you can see it in comparison with the old prototyping board here. I think it looks a little better. There are a few things I would change, I think. You can't actually see the labels on here very well. If we sort of zoom in, you can see that they are labelled up: arm, fingers, stomach. But once you've got the ribbon cables actually in, you can't really see the labels. So it might have been better to have the labels down here to the side. Would have been easier to read. Doesn't really matter, but... Now what I'm thinking is, I'm a bit nervous about turning this on. It's also going to be a little tricky because I need the Raspberry Pi connected back in to get it working, and I don't really want to reassemble everything in case there is a problem, because then I'll be dismantling it all again. But that is going to be a little tricky. We've got this ribbon cable coming around here, and that goes down to this arm, but I'm not totally convinced that I kept all the connections the same. So it might be a little dangerous to assume that everything's okay and just power this up, just in case there's a ground connected to one of the servo pins or something. So I think I really ought to test this out. I have made new boards for these. I've ordered them, but they could be about another couple of weeks before they arrive.
Right, okay. Shopping for us, and there might be some more circuit boards. Summon that up. Ooh, a puzzle that I can give this to Ralph if I want, but yeah, I'm gonna give it to him. Right, actually comes in bubble wrap. Yeah, we just need these.
So I've made up one of the circuit boards, assembled all the components on. We can see here, hopefully this looks a little neater than the original ones, which had that great big mess of wire on the back. That's now gone. We've got a couple of LEDs now as an addition, so you can see when the power is on. Unfortunately, because it is a little different, I'm going to need a new bracket to replace this one, and I've realised that I can't actually get that one out because I need to spread these 2 side pieces, these 2 grey bits here, need to be spread apart a bit so that we can get that bracket out, and I can't do that because there's a bolt running through it here with a nut on that side. So I think I'm going to have to take the forearm off so I could spread the bicep a bit and get the new bracket in. And speaking of the new bracket, let's take a look at what the printer is doing. Pretty tight.
Alright.
There we go.
Yay!
Might as well take this off. Driver. Take that out. Okay. There. Bit tight, but it's gone in.
Yeah. Successful.
So you can plug the bicep back on. So what I'm wondering here is to try and keep some of this cabling a little tidier, is I'm wondering if I could take the ribbon cable that's going to go down to the bicep and the power cables, they're also going to go down to the bicep. I'm wondering if I could take them through the shoulder here, down in there, and that will stop them from having to hang over the top of the shoulder here. Now ideally we would want them to go down into the bicep as well and go down that hole there, but I'm not going to do that right now because I think that will involve taking the bicep apart to get that done. But I thought we could do sort of half the job and at least hide the cables from running over top of here. But I think to do that I'm going to have to cut the plug off the end because it won't go through. I could also bring another ribbon cable and another power cable through there as well, because we're going to have another breakout servo board in here. So it might be a little tricky to see, but I've got 2 ribbon cables and 2 sets of power cables running through there now. And then they're going through there to the back of the robot. And we can see we've got 2 ribbon cables coming down here now. It's a little tricky to see because one's directly under the other, and that was the idea, to try and keep them neat. You can see what I was saying about not being able to read the labels on here now. I'll try and get in there. You can see we've got the shoulder here, and then I think just below we've got the arm. So the shoulder is going to be the board that goes in here, and the one that says arm is the board that's down here, the new board we put in there. So it's tidied it a bit. Main problem now is these should really be going through the bicep, but I think it's going to be a fairly major job to do that, so we'll tackle that another day. So I suppose I should try to make up a board to go in here. And I think I'm going to try and design a mount for it that can hopefully fit down into these slots just here where my finger is. You'll get the idea once I get it made up. Okay, back into the shoulder. I've designed and printed this little bracket. So I've got one of the breakout boards screwed in there. And I'm going to fix this into the shoulder here. That's the printer in the background printing another one. So I just need to put a screw down here. And another one on the other side in there. I'm going to have to try and drill a little hole to get it started, and then hopefully a couple of screws will hold that in. So I've got the power cables in there. Just here, red and black wires. Now I've left them a little long. I haven't cut them really tight, so that when the shoulder moves out we'll have a little bit of slack on the wire and hopefully it won't pull too tight. I've done the same on the ribbon cable. Left myself a bit of slack in there, so again it doesn't pull too tight. Okay, just push that in there. So it's reasonably neat. I don't know if we'll eventually put some covers over here or not. These won't be coming out of here because they should be going down through the bicep. So then what we've got then is the servo headers here. There's 6 on here, but we've just got 3 cables. I've got them all here. Should be 3. There's 2. Third one's hanging down the back here. So they can just plug onto these headers, but I'm not sure which one, so I'm going to have to check that out. And I think before I actually connect up the real shoulder servos, I'm just going to put a test servo on here just to make sure that everything seems okay. So I'm getting there now. Still looks a little bit messy with all these wires around here, but you can see I've got the second circuit board on the second Arduino. Got 2 ribbon cables here running up through and through the shoulder, exactly the same as the other side. I've got this circuit board connected, so I just need to screw that in. Need to terminate this one to plug onto that board. So that board's now screwed in. Look reasonably neat when they're at that stage. I could still. So again, I'll leave slack on the wires and on this ribbon cable. I'm not going to terminate this ribbon cable right now because I've been finding my normal method to terminate these IDC connectors is to put them in a vise, which is over on the bench, and I can't reach the bench when they're short like this. So I've been using a pair of long nose pliers to sort of close the crimps up, but that's not very good and it's been damaging some of them. So I've ordered myself a tool which should arrive tomorrow, so I'm not going to terminate this now because it is quite late now. I'm going to leave this until tomorrow. Hopefully the tool will turn up and we can terminate that there. I think the next major job is going to be to get this second forearm off so that we can fit the PCB in the back of the bicep here. And I will just say I'll do that off camera because I've yet again lost my little cameraman. He's out having fun with his friends. They've gone away on a trip to Wales. So at this point I started to notice some problems. I powered things up. I've got the screen kind of reattached. I've strapped it on there. I've got some issues with the screen actually. These cables don't really fit and it keeps damaging the connector in the side, so I've ordered a different cable, and for now I've just literally strapped it to the back of the robot with some big thick cable ties. Yeah, I powered it all up and I noticed that the 2 Arduinos in here, the left Arduino and the right Arduino, were not appearing in my robot lab. And I actually created myself a little scanning utility I can run from the command line to see when they're appearing and when they're not. And that was showing them as missing as well. I think the next major job is going to be to get this second forearm off so that we can fit the PCB in the back of the bicep here. And I will just say I'll do that off camera because I've yet again lost my little cameraman. He's out having fun with his friends. They've gone away on a trip to Wales. So I noticed with these boards seem to be working. I can turn on the power here and we can see the red light coming on. That's the power light. So that's correct, because these blue switches are my main power switches for the servo power. But I noticed that the little control light didn't come on, the yellow one here. Now that should come on when the Arduino is powered up, and the Arduino is powered through USB. So if I unplug this, I'm just going to unplug this cable here, but I'm going to put the camera on that light, and you'll see when I unplug it the light goes out, and if I plug it back in again, light comes back on. So that appears to be working. Same with the other side. Power is here. That's the I servos you can hear just powering up. And the USB power is here. It's on at the moment. If I take it off, we get nothing. So that's correct. But that wasn't happening. I wasn't getting these control lights on this side and this side, and the two Arduinos didn't seem to appear. Now I've done a bit of diagnostic and tracked it down. I did things like just unplug everything and then plug things in one at a time until you find out what the problem is. And it turned out to be these little circuit boards up in the shoulders here. I had a look on my schematics and I could see that one of the pins in the ribbon cable connector, it's actually the one with the square pad, should be connected to +5 volts, but the design on these little boards has got it connected to ground, which meant there was a dead short between +5 volt and ground. So I am planning to replace these boards eventually with some with LEDs on, and I didn't quite get the, can't see it here, but the power connector which is underneath. I used the wrong footprint and it was a bit tight, so I was never happy with these boards anyway, so I will replace them. But I think as a workaround I can just cut the solder tracks. So we'll go to the bench and take a look at one and we'll see if we can modify it. Okay, so this is the problem here. It's this pin in this corner here, which is +5 volts, and we can see it's connected to this pin here, goes up through this big track. If we turn that over, we'll see that that is actually our ground connections. The black connections there are ground, so we definitely don't want the ground connection. This pin must be ground as well. Connection here must be ground. We definitely don't want that connected to +5 volts because that's a dead short. So what I'm going to try and do is just cut that little solder track there. So I've just tried to remove a piece of the copper in here. Hopefully that will be fine. I might just have a look at it under a magnifying glass. So cutting that solder track seemed to have solved the problem. The Arduinos are appearing now in my robot lab again. So I believe that dead short was probably blowing a polyfuse in the Arduinos or something. I don't really know what sort of protection they've got, but they seem to be working again. The next problem I faced was I found they kept appearing on different USB port numbers. Whenever I unplugged and replugged in one of the USB cables, it would assign a new port number, which is pretty frustrating really. So I'm going to show you a quick way how we can solve that one. So in Linux we can actually create something called Udev Rules, and I'll show you the file which I edited. We cd into /etc/udev/rules.d, and if you do an ls in there, we'll see there's one file in there. I'm not sure if the file name is always the same, but I just edited the file that was already there. So if I show you what's in that, I just added 3 lines to the bottom of the file. So we've got action equals add, comma, attrs, id vendor equals, and then our vendor id, comma, attrs, id product, and then our product id, and then comma, symlink equals left mega. And then we've got the same again for the right mega and the same again for the nano. So what that will actually do is every time we plug in a USB device, it will check the vendor ID and product ID, and if they match one of these devices, it will create a symbolic link using one of our meaningful names. And what that ultimately means is that we can just use those meaningful names all the time now and not have to worry about what the actual USB port number is. Now, your vendor IDs and product IDs might differ from mine, depending on where you got your Arduino from, who the manufacturer actually was. Because I've got one genuine Arduino Mega and one which is a clone. And then I believe the Nano I've got is also a clone, not an original. And then if I run my little scan utility, I can see that all three devices have appeared and they now have sensible names. I'll show you the script that I wrote to do that. It's quite simple. You just got the shebang at the top with bin bash, and then we've got ls/dev, and then I'm piping that through to egrep. Just looking for the words Mega or Nano. Quite simple, really. Good?
Yep, that was great, guys.
So we'll leave it there for now. We've got the shoulders pretty much working. I'm not going to try the Onmo plates because I'm not confident about those yet. And we also had the stomach working at the same time as the two shoulders, so that's moving forwards, I believe. I haven't connected the head yet because I'm going to have to check all the connections in the head before we connect that up. Maybe we can do that next time. Thanks for watching, and I'll see you next time.